Okay, now we look at an approximation method for solving differential equations. So this is your introduction into approximation methods, numerical methods to solving differential equations. The first one we have that we look at is called Picards Method. It has nothing to do with Jean-Luc Picard from Star Trek: The Next Generation. It's spelled differently. But here is the formula. Y sub n of x equals y sub 0 plus the integral from x sub 0 to x of f of t y sub n minus 1 of t dt. And this goes for n natural numbers. So what I have to do is I have to get it in a form so that I can plug it in to this formula. So I need the differential equation in a certain form to be able to plug it into this formula. So I need it in this form of y prime equal to f of x, y. So I got to start off with this form, and of course I'm going to have an initial condition, y of x of 0 equals y of 0. So let's look at our first example. I've got the initial condition, but I don't have it exactly in that form. So let's take this and solve it. Y prime equals x minus 2xy. So this is my function x and y. So now I have my form. So I'm going to start off with y sub 0 equal to 0. That's from the initial condition given. So I want to go through and let's solve for y1. So y1 equals y sub 0, which is 0, plus the integral, here's x sub 0, right here is the 0. So this would be from integral from 0 to x, f of t, y, and in this case, n is 1, so 1 minus 1 is 0, y sub 0 of t dt. So let's plug in 0 plus the integral from 0 to x. So instead of x's, I'm going to put t's. Instead of y's, I'm going to put the y sub 0, but the y sub 0 in this case was 0. So it's f of t 0. So in this case, it would just be t, because it's t minus, and I'll go ahead and put it in here, 2 times t times 0 dt. So this part is all 0. So this would be the integral from 0 to x of t dt. So this would be t squared over 2 integrated from 0 to x. So this would be x squared over 2. So that's my y sub 1, x squared over 2. So now I'm going to plug in for y sub 2. Notice I still have 0 plus the integral from 0 to x. Now it's going to be f of t, y sub 1 of t dt. So this would be 0 plus the integral from 0 to x. So where I see an x, I'm going to put a t. So this would be t minus 2t. But instead of y this time, I'm going to put x squared over 2. So again, t squared over 2. That's in the place of this y right here. I put t squared over 2 because that's the y. That's my new y. And of course, dt. So what I end up with, the integral from 0 to x. So this would be t minus, the 2's cancel out, so it would be t cubed dt. So I get x minus, that'd be x squared over 2 minus x to the 4th over 4. Okay, so that's y sub 2. Now let's do y sub 3. So y sub 3 equals 0, I'll just skip the 0, integral from 0 to x, f of t, so again the x is t, minus 2t. What's y is this time? I'm going to plug in here. So it's going to be t squared over 2 minus t to the 4th over 4 dt. So now I've got that. Let's see what we get. We get the integral from 0 to x. And so this would be t. So this would be minus t cubed. This would be a plus t to the 5th over 2. How did I get that? The 2 over the 4 is 1/2. T times t to the 4th is t to the 5th. So what do I get here? I get x squared over 2 minus x to the 4th over 4. What do I get this time? I get plus x to the 6th over 12. Okay, one more time. Let's do it one more. Y to the 4th equals the integral from 0 to x. Again, it would be t minus 2t. What am I going to replace the y with? I'm going to replace the y with this. And instead of x's, t's. So this would be t squared over 2 minus t to the 4th over 4 plus t to the 6th over 12 dt. So what do I get? I get the integral from 0 to x of t minus t cubed. And if you haven't noticed, I'm getting the same thing that I had before, t to the 5th over 2. Now this next one, I'm going to get a minus t to the 7th. 2 over 12 is 6. 1/6. So now, let's integrate. So what am I going to get? I'm going to get x squared over 2, just like I got before, minus x to the 4th over 4, just like I got before, plus x to the 6th over 12, just like I got before. What am I going to get this time? I'm going to get minus x to the 8th. 8 times 6 is 48. So that's my y sub 4. Now, using a little calculus to remembering our formulas for our summations, remembering our series and what they converge to as n keeps on going, this will converge to 1/2 minus 1/2 e to the minus x squared. And that is my solution. But numerically, you would keep on going depending on how close you want to get, and there's all sorts of formulas to tell you how close you are, give you bounds, but I can find the series here. It's 1/2 minus 1/2 e to the minus x squared, because this is related to the e to the x formula. So that's Picards method. That's your introduction into numerical approximations, numerical for the solving of a differential equation.